In today's video, we're going to be going over some clean coding tips by refactoring an old homework assignment that I wrote years ago and just sort of applying some of the knowledge that I know today. So if you want to learn how to write cleaner code, more maintainable code, stick around. That's coming up next. What is going on, everyone? My name is Adam Abbott with Pragmatic Ways, and this is the YouTube channel for software engineers who just want to take their skills to the next level. You know, you want to learn how to start writing cleaner code, more maintainable code. You want to learn about design patterns, data structures, and algorithms. All the good things. We got it all here on this YouTube channel or over my blog at pragmaticways.com. We also have a Facebook group. If you're on Facebook, join our Facebook group. It's Software Engineering Mastermind Group. Link to that is down in the description below. But without any further ado, like I said in the intro here, today's video we're going to be taking over an old homework assignment that I wrote years ago. You know, one of the first homework assignments that I've ever written. You know, I barely knew anything about writing code or anything else. So we're going to be taking that homework assignment and just sort of seeing what I did wrong back then and just applying some clean coding tips on how to make that program a little bit better. So let's jump right into it. Alright, so the first thing to note here is that all the code that we're going to be going over in this tutorial today is going to be on my GitHub account, and a link to that will be in the description below. So again, what this is we're going to be going over an old homework assignment that I wrote years ago, one of the first homework assignments that I've ever written, and we're just going to be rewriting it, applying some clean coding tips that I know today that I've gained over the years of being a software engineer. Alright, so here are the program requirements. You can pause this video and read them for yourself in whatever speed you want, but I'm just going to breeze through these real quick. So, Joe's Pizza Palace needs a program to calculate the number of slices of pizza of any size can be divided into. The program should also report the number of pizzas someone should order for the party, assume each person at the party will eat 3 slices. The program should then prompt the user for the diameter of the pizzas they wish to order, and the number of people who will be attending the party. The program should then calculate and display the number of slices per pizza and the number of pizzas needed for the party. And then it gives us a few background information. You know, a slice must have an area of 14.125 inches. The number of slices per pizza is the area of the pizza divided by the area of a slice. And then it tells us that the area of a pizza is calculated with the area equals pi times r squared, radius squared, and then they want us to use pi, the constant pi, as 3.14159, and that tells us their r is the radius. And then the number of slices should be a fixed point and rounded to 1 decimal place, and then pi must be a named constant. Alright, so we can view the original source code here. This is the code, again, that I wrote for one of my first programming assignments ever back in college, years ago. All right, and then I guess second thing to note now that we're here, this particular homework assignment is written in C++. But for anyone that doesn't know C++, I don't want to steer you away just because of that. We're not going to be focused on the syntax of C++ here. We're really going to be focused on the clean coding aspect of it. All right, so even if you don't know C++, if you know Java or Python or any other object-oriented language, you should be able to get enough out of this tutorial still. Alright, so first thing we're going to do is I'm just going to run this inside of an online compiler. Alright, so I just typed into Google C++ online compiler, and I came to this one right here. So what I'm going to do then is go back into GitHub, and I'm just going to copy all of this code. And I'm going to Control-C that, and head back over into this online compiler, and Control-A, Control-V, and paste all of that. Alright, so now let's see what this code is doing here. Alright, so at the top of it, you know, I got my headers, I need to import all my dependencies that I'm using. And then in the actual main program here, we start off by declaring and initializing a few variables. And then I got this nice little comment here that explains what I'm doing next, and I'm prompting the user for the party info. You know, I'm getting the sizes of the pizza that I want, and then how many people are at the party. And then I'm performing these calculations, getting the pizza radius, pizza area, number of slices per pizza, as well as the number of pizzas needed for the party. And then once I got all the information, I just display the results as needed. And then the program ends. So let's go ahead and run this program right now, and let's just see what this looks like right out of the gate. All right, so I get prompted, what size pizza would you like? Enter the inch diameter of the pizza. So let's say this is a good size 16-inch pizza, and then how many people are at the party? Let's say there are 8 people at this party. And then it displays my results for me. It says pizza size is 16, because that's what I entered in. Number of slices is 14.2, given the area slice of a pizza was 14.125. If it's a 16-inch pizza, it does that math. Number of people at the party is 8. That's what I entered in. So the number of pizzas that we're going to need are 2. All right. So now let's go back in this code and let's actually start analyzing this and seeing how we can write it better. All right, so the first thing I want to draw our attention to right away is just how much stuff is going on inside of our main function here, right? This is our main function. This is supposed to be telling what our whole program is doing, but without these comments, I can't really get a good idea of what's actually going on here, just because there's so much. I mean, this main function is, what, it's a 6, 8, it's like 32 lines long, and that's just huge. You generally want to write nice and short, detailed functions that have one single purpose, and we can see this main function has a lot of different purposes. It's doing a lot of things. So that's the first rule here, is write small functions that do just one thing. Generally, you want to try and keep it within maybe 5 lines, maybe 10 if you really need, but I mean, anything over 20, 25 lines, that's generally insanely long for a function to be. So that's what we're going to start first. All right, we're going to be taking out, we'll start off with extracting out this user prompting the user for the information. We're going to extract out this logic here into their own separate function. And another thing here is yeah, it helped having the comment here, but Robert Martin has this great quote saying, what is it? It's don't use a comment when a proper function name or variable name would do much better. So that's what we're going to do here, like I said. All right, so we're going to just take all this information, or take all this logic and move it into its own function. So I'm going to start with this here. Instead of putting this inline here, what I'm really going to do here instead is I'm just going to say pizza diameter equals get pizza diameter from user. And then in order to do that, I need to create this function. So I will go ahead and do this here. And this is going to be an integer. So I'm just going to go ahead and copy and paste this here. And in order to do that, I need to declare a variable there. And now I can just return pizza die. So now I can take out these lines of code here. And I'm going to do the same thing for this. And I know it's going to be pretty much the same, so I really am just going to copy and paste that code here. But this one instead then is going to be not get pizza diameter, but get number of people at party. Get number of people at party. So now it might seem pretty absurd at just how long I'm naming this function, but realistically what we're going for here is clarity. Clarity is king. The easier it is to understand a function or a program even, the easier it is to make it maintainable, for other people to maintain it as the years go on. And that's honestly one of the biggest key points of writing code is how clean and easy to read can you make your code to be. All right, so I cleaned up those right away, and I moved those into their own function, but now notice here how these two functions look almost the exact same. And that's duplicate code, even if they're not exactly, like this sentence is a little bit different than this sentence, but the whole structure is I make an int, I prompt the user for something, I receive an int, and I return an int. Make an int, prompt the user, receive an int, turn it in. These functions are the exact same. This is duplicate code. So what I'm going to do instead then is I'm going to extract out this logic here into a shared function between both of them. So I'm not repeating this logic here. So I'm just going to say int, I'm going to get some boilerplate, get input. I'll even say get int input from user. And this message here, or this argument, this function here, will accept an argument of a string, and that will be the message we want to display to the user. And I haven't done C++ in a while, so I need to remember how I do that. String is not capitalized. All right. And then I can pretty much just, again, copy and paste here, just for the time being. And this is going to be input. And Control-C, Control-V, Control-V. And I'm going to C out this message variable here instead. And now what I can do is I will say in these functions here, what I'm really just going to do is return get input from user. And what I'm going to input them is a message. I'll say string message equals this bad boy here. All right, and let's just delete that so it looks a little bit cleaner. And this is complaining that I'm not passing it the message argument, so I will pass that as such. And then again, I can copy and paste this over here, but then change up this to be this. And there. So now that's cleaned up a lot better. And now if I run this program, it should run the exact same still. Nothing should have changed so far. I'll say 16 and then 2, or no, let me run that again actually. It's supposed to be 16 and then 8. And then the number of pizzas was equal to 2. And there we go. Same exact output, so I know I haven't screwed anything else up too drastically yet. Alright, so now the next thing I want us to really focus on is what I like to call the proximity principle. And proximity principle usually is more aligned with like user interface or user design type of things, but it also applies a little bit in software design. And what the proximity principle states is that you should try and keep like things together. Or another way I like to think of it is try and declare and initialize your variables as close to the implementation as possible. So we see that I declared all these variables that I'm going to use for this main function at the top, when most of them I don't really use until down here. So why do I declare all of them in this big lump right here? It just doesn't really make any sense. So I'm going to then take this double. Where did I have that one? Oh no, that's an int. Okay, so this pizza die here, I'm just going to say that's an int right there, and then I'm going to take him out of there, because this is the actual place where I actually use and need him. And then same thing with the number of people. I'm just going to do that and take him out of there with that. And now that cleans up that a little bit. And now I can a lot easier that, okay, I have an integer pizza diameter, and all this is really going to be assigned to is get pizza diameter from the user. Same thing with number of people. I can quickly and easily see that it's an integer without coming down here. Like beforehand, when I didn't have these, I would just see pizza diameter, and I'd have to go back up to the top of the program and be like, all right, well, it's pizza diameter again? Oh yeah, it was an integer. Okay, come back down here again and finish up reading the rest of this code. No, now it's just a quick and easy one-time swoop. Okay, I have an integer, it's a pizza diameter in a variable, and it's going to be assigned to whatever this function does, but the name is detailed enough that I can very easily understand what this function does without having to go into the function to actually see its implementation. Alright, so next thing we're going to do now is same thing. We're going to be extracting out these calculations into their own functions the same also. Alright, so I'm going to be getting the pizza radius here, and that equals the pizza diameter divided by 2. So instead, what I'm going to do, same thing, I'm going to take this double, and I'm going to say double pizza radius, and take that one out of there. And I should probably spell double correctly. There we go. And double pizza double pizza radius equals, what I'm really going to do here is assign it to a function, get pizza radius. And in order to get the radius, I'm going to need the diameter. So I'm just going to copy that right there, and then make this function up top here. And this function is going to return a double. And this is going to be an int, I believe, right? Yep, int. And then this one's pretty easy, though. All I need to do is just return this calculation. But again, by creating a named function with that, then I'm just extracting out, I'm hiding the implementation details and just giving a high-level detail inside the main program, so it's a lot easier for us to actually read. So I don't have to know how to get a pizza diameter. I can just read, okay, this is getting the pizza diameter. If the pizza diameter ever turns out to be wrong, and I have a feeling that that algorithm or whatever is inside that function is wrong, I know exactly where to go to analyze that or investigate that a little bit more. Instead of having to search somewhere within these 32 lines of this main function, I now have one place where I'm getting the pizza diameter. I know exactly where to go inside my program if I suspect something in there is wrong. So then continuing on here, I'm going to do the same thing again with this pizza area. Double pizza area equals, and because I named it up there, it's going to yell at me. All right. And same thing, I'm going to really just assign this to a function equals get pizza area. And then in order to get the pizza area, you need the pizza radius. Okay. And then copy this, and same thing down here. It's going to return a double. It's going to be that. It's going to be accepting a double this time. And then it's just going to return this function here, this calculation. And why are you yelling at me? Expected query expression. Did I spell it wrong? No. I have a parentheses here and not a bracket. There we go. And now we get to another one here, pi. Because I declared pi over here, but again, what I mentioned about the proximity principle, I don't use pi until down here, and this is the only place I actually use pi. So why do I even need to declare it in my main function in the first place? I don't. So I'm going to take this out actually, and just move that up there. And I'm just going to declare that inline that right there. And now pi is contained within this function because only this function actually cares about this constant pi. So I don't need to, flood the rest of my program with another constant that's not used for 99% of the rest of the code. Now it's just contained, the scope of it is a lot more isolated inside this one function only. And I can delete this line now. And then the same exact thing goes for this one here. We're going to be doing the same thing. It's all pretty standard at this point. We can kind of see where most of this program, or where most of the ideas that we're going for here is create smaller functions, declare your variables a lot closer to their actual implementation, and try and limit every function scope to the smallest amount possible. All right, so number of slices per pizza. This one I'm actually going to and I probably should have said calculate pizza area instead also. So I'm going to say calculate because that tells a better story. Because that's what I'm actually doing. And this one also should be calculate pizza radius from the pizza diameter. Because up here I'm actually getting user input, right? But right here I'm not getting anything. I'm not really calculating something. And then same thing right here. I'm going to say calculate number of slices, cannot type, per pizza. And then in order to do that, I do need the pizza area to be passed into there. And now it's complaining a couple things. A, I already declared this variable up here, and B, I do not have this function declared anywhere. So let's take care of that right now. And this is going to return a double. It's going to be named that. I'm going to use curly braces this time. And all this one's going to do is just return this function here, or algorithm rather. And I got a couple areas, identifier, pizza area. Oh, because it doesn't know what that is. So I need to make that a double. And then same thing right here. I can now take out this constant from main and isolate it within this one function here. All right. And then it's complaining about that, so I will delete that bad boy right there. And then same thing over here. This one is now an integer. And I can take that out. And this integer is really going to equal a function. And that's going to be calculate number of pizzas needed. And in order to calculate that, I need the number of people as well as the slices per person, as well as the slices per pizza. So slices per person, I can bring that directly inside the function itself. But for these two, I do need to pass in two of these variables here. So I'm going to pass in the number of pizza variable, as well as the number of slices variable. Okay. And then I'll just copy that, make sure I grab that C in there. It's going to return the int, so let's declare this up here. Int equals that, does that. Number of people is an integer versus number of slices is a double. So I put those data types on there for that. Okay. And then it's just going to do this calculation here. I'm just going to return that calculation. And it doesn't know what number or slices per person is, so I will extract that now from the main and put it down there. And then I can delete that. So now we can see my main function is a heck of a lot cleaner. I didn't, make it all ugly with all those variable declarations and some initializations at the top of it. Now I just declare them when I actually need them. And I don't even need that function or that comment in there explaining that calculations are here, because I can clearly see that these are all calculations. All right, so one tip on finding ways to try and clean up your functions is to just take a step back and go back to the program requirements. Let's make sure that we're actually doing what we're supposed to be doing in the first place. Okay, so I'm going to go back to the program requirements here, just sort of reread these and make sure we're still aligned with what we're supposed to be doing. So the program should prompt the user for the diameter of the pizzas they wish to order. All right, now I do that first. I say get pizza diameter from the user, and the number of people who will be attending at the party. That's actually the second thing I do. I first get the diameter of the pizza, then I get the number of people at the party. Okay, so far so good. Then the program should calculate and display the number of slices per pizza and the number of pizzas needed for the party. That's the next thing it should do per the requirements. So I do kind of do that, but in order to do that, I do these extra couple steps here that aren't necessarily a part of the actual program requirements, but we know that in order to meet the requirements, we do need these. But again, these weren't actually called out as part of the requirements. So why are we exposing this logic to our main function here? Because the only purpose of this logic here is to aid in this one part of our requirements. So we should abstract rather this logic to sort of a lower level. This main function here should be a very high level overview of what our program is doing. But these down here, these are lower level implementation details that don't really need to be as visible as the main program. So I'm going to take these out, and I'm really just going to put them inside of this function here, because that's the only place we actually need them at. Okay, and then in order to do that, I no longer need the pizza area parameter, but I need the pizza diameter. And then same thing, all I need to do now is just pass in that. So now that cleans up main a little bit more. And now it comes to displaying the results. And again, if you don't know C++, this probably looks pretty ugly. And I'm not going to lie, looking back at it years later, this definitely looks pretty ugly, especially because I haven't touched C++ in, since college. So let's definitely extract out this information into its own function here. Alright, so again, I'm just going to be following the program requirements here, and all they want us to do is display the number of slices per pizza, and then display the number of pizzas needed at the party. Don't go above and beyond if you don't need to. That actually is a principle, the Yagni principle. You ain't gonna need it. It's an acronym. You ain't gonna need it. Don't design stuff for future end in mind, or don't design something just because you think it's gonna be great and grand. You're just wasting time. If it's not gonna be needed, then don't do it. Don't waste time actually doing it. That's the Yagni principle. So I'm gonna go ahead and take out this line here because it never asked me to display the pizza size. And then it also never asked me to display, the number of pizza at the party. It only asked me to display the number of slices per pizza and the number of pizzas needed at the party. So I'm going to take out this redundant comment here because what I'm going to do instead is display results. And this display results function is really just going to take the number of slices per pizza as well as the number of pizzas needed. And then I will X out those and put a function here, and just to verify, first one is a double, second one is an integer. Okay. And then display results. First one I said was a double, I don't remember the name of it, and second one was an int, I also don't remember the name of it. But I know it needs to do that, and that was the first one there. Number of slices per pizza. And then number of pizzas needed. And it returns void. It doesn't actually return anything. And there. Now I can look at this, and actually I can also delete that, because if you're a newer programmer, you shouldn't be using system pause just to end the program. If anything, put in a breakpoint or something. And I'm also going to move up my curly brace to the function declaration line as per Java's convention. Okay. So now this is my main program, and we can see I condensed it from, 32 lines I think we said, now to just 10. This main program is 10 lines of code long only, and it really tells a story. We can actually read it top to bottom now and just read the story, saying, okay, first we're getting the pizza diameter, then we're getting the number of people at the party, then we're calculating the number of slices per pizza, and then calculating the number of pizzas needed, and then we're just displaying the results. And that's exactly what the program requirement said. And if I run my program, it should run the exact same ways it ran before. What size pizza would you like? 16. How many people at the party? There are still 8. And now all I need to show is the number of slices per pizza and the number of pizzas needed for the party. So let's just go ahead and now recap some of the clean coding tips that we went over. All right, so we're going to go back into the old program here, the first one ever written. I declared all these functions at the top of the program, but some of them I only used once and not until way later in the program. So let's follow the proximity principle and try and declare your function or your variables as close to your implementation as possible. And with that, try and limit its scope as much as possible. Because I made this a constant so no one else can change him, but pizza radius, pizza area, all these other ones are not constants. These are all exposed to everything else within this main function. Anyone else can accidentally update this variable when they didn't need to. So try and limit every single variable's exposure as much as possible. And you can do that by creating very detailed, very targeted, single-purpose functions. So that's the next thing. Don't use comments when a function would suffice instead, when a function would do much better. And that's exactly what we did here. We didn't put comments saying start getting users input. We just created comments. This variable equals what I'm saying to do. Get pizza diameter from user, get the user's input. Same thing right here. So don't use comments just because you want to use a comment. It's kind of redundant, and it also, there's no point. It would be much easier and much better to extract out this information into its own function with a properly named function name. And then same thing down here. I create all these different calculations here. I even have this redundant comment on here that says calculations. Most of these are not needed for the program requirements directly, but they are needed indirectly. So since they're needed indirectly, I should bury this implementation details into lower levels of the program by creating them again into their own functions. And at the end, for people who are not C++ programmers like myself these days, seeing anything like this is pretty scary. So we want to extract out this information, again, into its own function. That way we can see something nice and pretty, such as display results. And then it's very clear to us to know what that's actually doing versus seeing all this stuff here. So that's pretty much all I have for you. If you liked this video, make sure you smash that thumbs up button. Make sure you subscribe, share with all your friends and family. Head over to my blog or Facebook page for Pragmatic Ways, pragmaticways.com. Yeah, if you liked this, a lot of this code here, a lot of this clean code tips came from a book called Clean Code by Robert Martin. I have a whole blog article on the couple books that all newer programmers should absolutely read prior to getting their first job in the real world as a software engineer. And this book is by hands down one of the first books that you should be reading. So again, head over to my blog. I'll have a link to that specific article and this book in the description below, but I highly encourage all programmers to read a copy of that book there. And actually, since I'm here, let's just go ahead and check out what that blog article looks like so you know exactly where to look for that. And there it is. There's my ugly mug right there with the book that I'm recommending, the Clean Code book by Robert Uncle Bob Martin. It is such a powerful book that all programmers, again, should just absolutely read prior to getting their first job. So that's about it. Wrapping up here. Without any further ado, again, thanks for programming with me today, cleaning up some old code from one of my first homework assignments, and I'll see you all next time.